Okay, welcome to the next lecture. And in this lecture, we're going to be talking about servlets. So first, to understand how servlets work, you've got to understand how the HTTP protocol works. And I've given you a little bit of an overview in the previous lecture, but here I'm going to go into the nuts and bolts of it in much more detail. Once we've got clear on HTTP, we can then talk about how servlets can be used to handle HTTP requests and respond to them, with different kinds of data. A little bit of motivation, don't know if you can read this, but this is like a job ad. Excuse me. Pardon me. For a Java programmer. So this one's like 30 to 45K, but maybe if you're starting at a junior level, you're not going to get quite as much. But this is like a fantastic opportunity, blah, blah, and we're talking Java Enterprise Edition, servlets, probably be stuff with HTML, XHTML, CSS, so on and so forth. It's not a million miles from the sort of job I did at Trinity Mirror, where it's like a blend of technologies used to deliver like a commercial scale website or commercial scale internet application. So, there's cash in this. That's the message here. Okay, so the HTTP protocol. So the sort of originally, it was all about exchanging HTML. So you want to request HTML documents as part of the sort of World Wide Web. That's where HTTP came from. But now it's used commonly to exchange other data in other formats, such as JavaScript object notation, which we'll cover in the next lecture, I think, and XML, and maybe other stuff as well. So it's an incredibly simple and convenient protocol that's will work across a wide range of systems and has a wide range of applications. So it's expanded beyond the narrow limits of just sending HTML or images and stuff across the net. So HTTP is usually transmitted by TCP, but as I said, this is not in no way essential. HTTP is just a protocol. If you want to use donkeys, nuns riding donkeys to send HTTP messages around, then that's absolutely fine too. Protocols governing the format of the message, how to interpret the ones and the noughts. If you send a GET, the appropriate thing to do is send the response that has the status message and the response code and all the rest of it. That's what HTTP is about. It's not about a specific set of technologies that are used to send it, even though a specific set of technologies is usually used to send it. So typical HTTP session, so we have the server sitting, Apache server, whatever, which is a program that's opened a socket on a particular port on a particular machine somewhere in the world. Then we have the HTTP client, which is like a browser on your local machine or on your phone or whatever, and then you type in a URL to that browser, and then first your client's going to use the computer to do a DNS resolution, right? It's going to convert that URL into an IP address. Then the client, once it's got the IP address, will establish a TCP connection to port on the server. So the server's listening on this port, maybe 80, something like that. So the client, when it's found the IP address, will contact the server on that particular IP address, that particular port, send a GET message, if that's what the user wants, to the server. The server will receive the GET message, look for the document or generate an appropriate document, and send back a response. So that's the typical HTTP session. It's stateless, as we're going to cover. So, once the client sent back a response, once the server sent back a response, that's it. It forgets about you unless you've used specific mechanisms to check or track the user across HTTP interactions. So that's a little example. Might be familiar from the previous talk. So here we send a GET request. It has a particular header with GET, the page we want, and a few other bits and bobs. And then we get back the response. It tells us there's 200, the status message response code, that it's OK, which is all good, and a few bits and bobs. And we send the GET, and what we get back is a header, but also we get the body, which contains this HTML, which the browser can then render and display as the web page. So that's the headers. In response to this header, we get that header. And then we have the actual body. The GET request doesn't have a body, and the response has this body containing the HTML data. Now, HTTP has a number of key methods. It's got quite a few methods, but the ones that we really care about are put, delete, get, and post. Now, you can use these for any old thing because the server itself can choose to do what it likes when it receives a delete message, for example, but there's sort of kind of conventions about how these things should be used. And a popular convention is this idea of a representational state transfer, or RESTful. So that in this way of interpreting HTTP messages, they're used to manipulate resources. So I'm using these messages to change resources that are on the server. And these resources have URLs, or uniform resource identifiers, or uniform resource locators, depending on how you want to phrase it. So we've got, so these are the ways in which the HTTP methods are interpreted in this RESTful framework. So we have put. When we send a put method to the server using HTTP, what we're trying to do is to create a new resource. When we send a delete message, we're trying to destroy a resource. Get is to retrieve a resource, and post is to change the state of a current resource. That's the idea. So the resources on the server, we're using these HTTP methods to manipulate these resources. That's the idea. And these are all stateless interactions. So let's take a little example. So here we have these are sort of message number or something. So let's say we send get to this universal resource identifier. We send that URL, and that will return a list of the users, because it's sending a get method to that URL. And if we have get to this URI, then we're getting a particular user. It's a read-only. We're just accessing the state of that data. If we do put, then we're adding that user with the ID 2. If we're doing post, we're updating that user. Delete, we're deleting the user. And options, you give various different kinds of options with HTTP as well. So there's other HTTP methods. Remember, an HTTP method is what goes into the request here, whether it's a get or post, response, delete, options, and so on. So head, you send off a head method, and you just retrieve the header for that particular resource. Trace echoes it, options turn the methods that's supported for the specific URL, connect through specific channels, patch. So there's various bits and bobs you don't have to worry about too much. But just the thing to remember is that HTTP defines a large number of different methods, of which 4 are the key ones, which are get, put, post, and delete. Okay. Now the HTTP response to get, for example, can have one of a number of different status codes. So the one you're hoping for is OK, that the server's found the resource and it sent it back to you, or it's updated the resource or whatever. But you can also get like bad request, some kind of error in the header, for example. Or if it can't find the resource, then it'll give you a 404 error, or the service unavailable error, maybe the database is down, it's overloaded, whatever. There's an enormous number of these things, and you can look them up online if you're interested. And that's in the response, that's the 200. So with the servlet, you can access the header and find out whether it's the status code and all this kind of stuff if you want to. Okay, so that's a little bit more on HTTP, and now we can talk about how servlets can be used to handle HTTP requests, and this is what you're going to be using in your project to do that for you. So server is a bit of software that runs on a computer and listens on a particular port. And a server will respond to HTTP requests with the contents of a file or execute some kind of command that dynamically generates content. We'll go into this in a little bit more detail in the lecture on commercial websites. So yeah, they often execute scripts written in PHP, .NET, JavaScript, etc., whatever. In this course, we're going to be using Java on the server side to generate responses to GET requests. We're going to different ways in which you could use server-side Java. So, because I'm basing this course on Java, I wanted a way in which you could use Java to respond to GET requests, and I could have done this in different ways. There's things like Java server pages, which is this weird, slightly kind of crufty mixture of kind of Java code interposed with HTML code, a bit like PHP, I think. I've never used it, but it's a bit funny and not that powerful, really, and probably not that well used. Most people probably use PHP instead of Java server pages, I imagine. You see the odd website with JSP pages, but I wouldn't bother with this myself. Second way you could do this is you could create your own standalone server implemented in Java. So you have your own server that sits there listening to the HTTP requests and then responds with web pages or whatever. The tricky thing about your own server is you have to do absolutely everything yourself, including if you just want to reply with a simple static web page, then you've got to bother loading the web page up yourself. I kind of like this Java HTTP server. I think it's great, but it's possibly not the best place to start. So the servlet, and also, yeah, most people wouldn't want to, for the Internet of Things, I'm going to show you how to use the server, but if you were running an actual commercial website, you'd probably want a server. You wouldn't run your own HTTP server, you'd run a server that handled lots of different kinds of things automatically, and then you could add your own functionality to it. And that's where this HTTP servlet comes in. So a servlet is like a little mini bit of Java code that's executed by the server in response to certain kinds of requests. So you deploy your HTTP servlet within Tomcat, and then Glassfish or Apache will run, and that Tomcat sort of runs within Glassfish or Apache, and whenever the server receives a request with a particular URL, it will invoke the bit of Java code you've deployed, and that Java code will then generate the response to the HTTP message. So this is what we're going to be using here. And the nice thing about servlets is they're dead easy to use in NetBeans. So there's no complications about getting them running or deploying them or writing XML files for the web XML or any of that. I'll show you how to use them. They're very easy to use, and that enables you to dynamically generate HTML in Java and use Java to access cloud-based web services. Right, so the Java HTTP servlet is the choice for the autumn term. It's a Java class that handles HTTP requests. It can read data from the clients in terms of forms. It can process data, interface with databases. It's got all the full functionality of Java. That's what's nice about it. And it's very easy to send data back to clients just by writing to the output stream of the HTTP response. So it's full Java. And you can make it secure in various different ways, probably with secure socket layer and stuff, but we're not covering any of that in this course. So if you want to see all the complete set of methods, there's the API for it there, which a little screenshot there shows all the different things you can do with a servlet. And the important thing, if you're using servlets properly in a commercial setting, then you need to be aware of the Servlet Lifecycle, and this might also be important in the context of your mini projects. So the servlet's running in Tomcat, and then the server that's running the servlet starts up, right? At some point, you sort of start the thing running, switch the computer on, whatever, and it boots up. So when the first time that the server boots up, it calls this init method on the servlet. Before it receives any requests, it'll call init on it. Then the servlet's sitting there receiving all these requests from people sending, requesting web pages, posting form data, all the rest of it. That's what calls the service method, and the service method breaks down into do get, do post, which I'll explain in a little bit. And then finally, if the server's shut down cleanly, at the end of the shutdown process, you'll get this destroy method called on the servlet, and then you can do whatever you like, close connections, close sockets, whatever you're doing in this servlet. So the context of your project, the sensible thing to do would be, remember you're communicating with cloud services and all that, so in the init method, you could set up the cloud communication, for example. The service method will then access the cloud to pull the data, and the destroy method will close down the cloud communication. And the servlet has these different methods you can use to handle HTTP requests. The ones that, it's got more, but the ones we care about, do get, do post, do delete, and do put. And you can see it's basically do appended onto the, pre-appended onto the appropriate HTTP method. So to implement these, you just have to override them, and I'll give you an example in the servlet. You just implement them in the servlet, and then automatically, whenever the servlet receives a get request, this will be routed to this method. I'll show you how to do that in a second. So the do get has this HTTP servlet request, and that has everything you might want to know about the request. What it's asking for, the query string, all that kind of stuff. Yeah, so it's everything you need to know about the request. You can get cookies in the request, you can get the header, query string, remote address, parameter names, all the rest of it. So anything you might want to find out about the get request and pull out of the header, you can get out of that HTTP servlet request. And then we got the response. And the response enables you to manipulate what's sent back to the server. So you can add a cookie, and then you can write the HTML into the response. and you can set the status. Is it 200? Is it 400? All that kind of stuff. So you can completely change, alter, construct everything that's sent back to the client. So the client's sitting there, somewhere in Chrome, typed a GET request. You can read everything about that GET request and control everything that's sent back to that client. So it's an incredibly powerful, useful set of classes here. So HTTP is stateless. You send a GET, you get the response. That's it, job done as far as HTTP. It's all over. Servlet processes the request, sends back the response. If you want to track users across time, maybe they're doing shopping, and so you want to add things to a basket. Maybe you want to do sinister things about predicting their buying patterns online. Then you need to use some kind of mechanism to track them across sessions. So they have cookies. You can drop a cookie on the user's computer filled with data about the user. More modern way of doing that is with HTML local storage, where you can use JavaScript to basically store lots and lots of different bits of data on the user's computer. Web forms, you can track as they work through a sequence of forms. You can hide variables in the web forms. And the URL itself, as you've seen, has this series of fields and values which you can use to store data. Probably not going to bother with that mini project one. I'm just telling you about it because it's important information to know. So as I said, the servlet itself runs within a server. So, something like Apache will have a servlet container, such as Tomcat, and then Tomcat will have the servlets, and there's like this web XML form, which descriptor thing, which I'll show you, which contains the relationship between the classes and the URLs that map onto those classes. So I'll explain that all to you when I do an example, but it's something to be aware of. So the web browser contacts the server, and because it's a particular URL specified in web XML, it will then call the servlets program to handle the request, which maybe will interact with the database and then send back the HTML, which goes back to the database, goes back to the user, sorry, the client. As I said, to make it work, we need to, so you can't just run the servlet by itself. It needs to run in a web container in a server. So you can deploy it yourself. You just need to adjust this configuration file. I think that's a web XML file, and you need to add. So here this contains like the servlet name, the name of the servlet. I think that's the class. Oh, that's the class. So that's just a random name, I think, whatever you want. This is the class that actually handles, and this class needs to be an appropriate part of the Tomcat or whatever, or it'll never find it. And here's got a mapping between the, I see, so the name here links up with the name here. So you've got the name of the servlet and the class that it's going to use to execute in response to requests. And here you can map between this servlet and this URL pattern. So whenever the user types in /hello world, it executes, or whenever the user sends a GET request to hello world, it will execute do get on the servlet in that class. So you can do it all manually, but fortunately, NetBeans and Glassfish works like a dream, you know. So you can just create your code, click and run, and you get a servlet running in under 5 minutes, as I'll show you. So we don't have to worry about that, but if you're doing this commercially, then you might have to deploy things in Tomcat in a more systematic way. So I'll give you a very simple example. So this is the HTTP servlet. So we're going to have a class that extends this HTTP servlet class, and then we're going to override one of those one method, in this case do get. And there, as I said, you've got the servlet request, servlet response. And what we do is we set the content type. So you can, I can't remember the content types, but you can probably set like images or files or send different kinds of things. And then we get the writer. So the response has a writer in it, which enables us to write things to response. And what we write into the response gets sent back to the client. So in this case, we're doing out print line, getting out, which is the writer. We're doing out print line, and this is just a little bit of HTML, which we're sending back to the user. So in practice, we could either like have a much more extended web page. This is a proper web page, right? Or in your projects, you're more likely to be writing the response back in JSON format or XML or something, because you're not sending the whole page back. You're just sending a little bit of data back, which can then be incorporated into the web page. Okay, so I'm going to give you a demo from scratch, and this demo, will show you pretty much how to do the first couple of bits of your project. So it's worth having a little watch. Okay, so here we have NetBeans, empty version of NetBeans. Now, if you're installing it on your laptop at home, make sure you install the Enterprise edition not just the standard edition, because it's the enterprise edition of NetBeans that has all the different useful stuff with servlets and other things I'm going to cover in the next term. And I'll show you what you'll see if you don't have the enterprise edition. So anyway, so let's have so we'll create a new project. And you see, if you haven't got the enterprise edition, you probably won't see Java Web or any of this. These are different kinds of modules that you can install with NetBeans. If you just install the minimal version, you're just going to end up with that maybe. But what we want is one that has the Java Web as a possible project type. So we select Java Web, Web Application, click Next, and give it a name. So I'm storing it in temp. Let's call it, give it a more useful name, CCE Web App, something like that, okay? So that's the name of our project. Doesn't really matter what it's called. Okay. And then here, you also, by the way, when you install this, if you install it on your laptop at home, make sure you install the Glassfish server. Install everything, basically. You don't need C++, but you need pretty much all of the bits and bobs. So you need the Glassfish server, which is what we're going to be using here. And then we have context path, which is like the URL that will be mapped onto this particular web application. So we'll see that in a second. So if you click Next, you get a load of stuff which you don't want, and we just click Finish. Right, so the first thing you get in your web application is this structure. So we got web pages, source packages, libraries, configuration files. So we don't really care about them too much. Web pages and source packages we do care about. So web pages, it gives you a default index.html. Now, when you're actually doing your mini project 1, I strongly recommend that you start in this way. That you start with a web application and with index.html like this. And then you take that index.html and you transform that into your beautiful web page. Because otherwise, you're going to end up with like funny difficulties with paths. Or if you've created your HTML somewhere else, you cut it and paste it into this document. Because then you'll have no problems and it'll just run easily. Or start in this way with your mini project and edit this, because NetBeans has got some nice ways of debugging and writing HTML, so it's a pretty good environment for actually writing this stuff. So let's just change the content briefly. So we'll call this CCE 3110 example web page. Okay, pretty specific. Okay, so now you see we've selected Chrome as our default browser, and here we just press play to run it. Now, for some reason, I haven't got the debugging thing working in here in Chrome, but when it is working, you'll see a little yellow bar up here, which shows you that it's debugging. When it's debugging, as you dynamically type HTML, it appears here. Okay, so here we go. So this is localhost 8080, that's the port, and then on that port, we got what I gave for the URL of this web application is CCE web app. Okay, and here we have CCE 110 example web page, what we typed in. So what we're viewing here is the index.html file here. Okay. Now what we want to do is add our servlet. So click on source packages, default package will do, whatever that is. We select new servlet. All right, I hope you can see that. New servlet, and here we have new servlet. So we'll call this CCE servlet. Okay, give it a name, that's the name of the class. Project's fine, location, that's just the file. And we must, well worth adding that information to the deployment descriptor. I've never not done that, so I can't tell you what it does. And there we have we call that, and this is the URL. This is how we access that servlet. So when we go to that URL, it will invoke the methods on this class. So just to make that super clear, we'll give it a different URL from the actual name. We'll call it CCE 3110 servlet URL. Okay. So here we go. So here we have our servlet, and this is the default servlet that you get created. So this we have process request, which isn't terribly helpful, but that processes any old HTTP request, because if you look, we've got do get here, do post, you could probably add in do delete or whatever, but do get, but these methods are just calling process request, which isn't exactly what we want here. So if we go back to the slides, which you have a copy of, where's my simple example? So what we do is just copy this, and we'll paste that into the servlet. And so instead of process request, which is this generic HTML, not do post, we'll do gets. So we'll paste it in there. So basically setting the response type, getting the writer, and printing out hello from CCE 310 servlet. And let's change that a little bit so it's very clear what we're doing. We'll just add test one with a funny E, right? Test one. All right. No, test exclamation. Well, test exclamation mark. Let's go for that. Okay. So we've got do get now. So whenever this receives a do get, then it should output that. Okay, that's the idea. So save it, and then we will run the project. So when we run the project, it again goes. What it launches is CCE web app. What it's actually calling is index.html, I think. Yep, it's calling index.html. But if we want to access the servlet and see what the servlet's up to, then we need to go to the path for the servlet. And to find the path for the servlet, we need to look in the web XML descriptor. So we've got web. As I told you, there's like a, so if we go into, let's get back from the beginning, right, so there's our project folder. In there we've got build, whatever, that's probably classes and stuff, NetBeans stuff, source, which has the Java source, the servlet source code, then web. Inside web, we've got the index.html file that we've seen in the project. We also got a web inf folder, and here we've got the web XML thing, which is what the server uses to map the class, map the URL onto the particular class that's executed. Now, if we look in here, we can see there's our servlet. That's the name, that's the class we've created, and this is the URL. Okay, so if we want to access our servlet and see what it's outputting, we just go to our web app / the URL. And there we go, it's working. So this, our browser now is sending a message, a GET request to this URL. And the server, Glassfish server, is using this web XML file to map that URL onto that class, which will be installed in it somewhere, it knows where it is. And when it calls that class, which is our CCE 310 servlet, it's a GET request, so it's mapped onto do get. And so what we're doing is setting the content type, writing out the, and then outputting a simple response. So when I come to testing my servlet, I can easily test what it's actually showing, the Java class, what the Java's outputting, by going to that URL. And I can also see the index page. So in your mini projects, you'll be making this index page sort of super complex and beautiful. You'll be adding some JavaScript to this index page. And that JavaScript will then be talking to the servlet. It'll be pulling this data or other data from the servlet and using that to dynamically update the content of the index page, or whichever page you like. And so in your mini projects, you'll have this do get method, and instead of just writing out some simple stuff, what you'll do is you'll use Amazon. You'll have a bit of code, which I'll give you, which will explain how you can then pull data from Amazon S3, combine that with a little bit of HTML or not, or just put it in JSON format, whatever, and then you'll just write it out here in exactly the same way, and then the JavaScript will receive that data and use it to update the web page. That's the idea. But as you can see, in this way, it's very easy to build, just to have an index page and a servlet, and they'll be able to talk to each other if they're running on the same domain. If you have your index page separately, it probably won't be able to access the servlet using XML HTTP request because of cross-domain validation stuff. So this is the way I recommend you do your mini project, in short. Okay. So let's go back to the talk. So I've given you a very brief, well, brief-ish discussion of servlets and how we can create servlets in NetBeans and combine them with the static pages that communicate with the servlets. Just going to say a little bit more about web services and message formats. So in this case, in our case that I've just shown you, we're returning HTML from the servlet, which is a typical classic sort of use. But you can also return messages in lots of different formats. So we've talked about HTML, but you can also return XML messages, return messages in JSON or in SOAP format, which is a version of XML, particular use of XML. So this is HTML, which you probably come across. Slightly more complicated example than the one I showed you. Then XML, you may have come across. What you have is tags. It's a bit like HTML in the sense you have, so HTML you've got lots of tags like head/head, body/body, and then you're formatting the data by having like an opening tag and a closing tag with certain kinds of properties. So here XML is like a data formatting, right, sort of a way of structuring a set of data and giving it meaning, I suppose, would be one way of putting it. So here we have a recipe tag that says this is the start of a recipe, this is the end of a recipe, and then you give it a title and have ingredients and a list of ingredients and so on and so forth. So the tags are enclosing the data, structuring the data, and giving the data meaning. That's XML. XML, as you can see, the ratio of words to data, sort of XML to data, is quite high. There's a lot of space taken up with the actual XML tags. So these days people are moving more towards JSON, which is also meaningful in the sense that it has meaning, but it's much more compact and takes up less network bandwidth. So JSON is called JavaScript object notation because it's very easy to use and it's sort of natural to using with JavaScript, but you can also use it in Java or any kind of other languages as well. And what you have here is a set of, I don't know if I've got a simpler example. No, this is probably the simplest example. I'm going to go into this more detail in the next talk, but we have, you have like the curly braces, and then you have keys and values. So this is a key, and this is an array, which is what the square brackets means. It's an array of values, and this is like a set of two objects. Like this is one JSON object, another JSON object, and the objects themselves can have like further keys and values and so on and so forth. So it's like a set of combination of keys and values structured into arrays and organized in different ways. So anyway, it's a more compact way of organizing a set of data and linking, names for different parts of the data with their actual values. And then we've got SOAP, which is a way in which applications can talk to each other using HTTP. So, SOAP can work over lots of different protocols, pen and paper, whatever, it doesn't really matter. But it's how you can use HTTP for a word processing document to talk to a spell checker, heaven knows what you'd use it for. But different applications can use HTTP to talk to each other and exchange messages. And that's what SOAP does. So you have the typical HTTP header, but instead of the HTML, you've got the XML. And this is like a SOAP. This is the SOAP header and the SOAP body that has, get stock price in this case, which is like a stock price request. Maybe it's like some kind of enterprise system using SOAP to communicate stock prices and request stock prices and so on and so forth. So it's a way in which, we talked about encapsulation, is a way in which application data can itself be encapsulated within HTTP, and the application data has its own header and body. And there'd be the response, so this would be like get stock price response, and then there'll be the actual price and the response, and then this would be the sort of way you're sending it and all the rest of it. Okay, so this talk, we covered HTTP and how we can use Java servlets to handle HTTP messages. Next lecture, I'm going to talk about how you can get data from the web using web services, web scraping, and that kind of stuff.